So before we get started, we need to know some important definitions that relate to circles. The first term is going to be the point of tangency. This is defined as the point where a circle and a tangent line, which remember that's a line that touches a circle only one time, exactly one time. The point of tangency is where a circle and a tangent line intersect. So you can see that right here. This would be a point of tangency for the circle and that tangent line that you see drawn outside of it. The second term that we need to look at is secant. A secant is different than a tangent. A tangent, remember, only intersects a circle one time. A secant, you can think of it as second. It intersects the circle a second time. Secant and second. It intersects the circle two times. So it goes across the circle somehow, and it intersects that circle in 2 points. And then obviously, like we talked about, the tangent is a line in the plane of the circle, and it intersects only 1 point. So the important thing about a tangent is it only touches that circle one time. The secant, remember, secant second. It touches it a second time. It intersects it twice. Secant is also your ticket out the door password. So make sure you have that down. Secant, S-E-C-A-N-T, secant. That is your ticket out the door password for today. Here are some important definitions. The inscribed angle theorem applies to angle BDA here. Remember, we talked about the inscribed angle theorem already before. That's an angle where the vertex is on the circle. And then notice now we're going to add in our new terminology. The sides of this angle are a chord and a secant. So here's a chord going straight across. And a chord is just a portion of a secant. So AD is a secant, or is a chord. It's a portion of the secant. And then BD is a secant. It goes all the way through. Remember, it's a line. A secant is a line. So it's got those arrows on the end, whereas a chord is a segment. So it's a segment of that secant line. So BD would be a secant, whereas DA or AD would be a chord. But the important thing here is to remember our inscribed angle theorem. Angle BDA would be half the measure of arc AB. But notice that that makes up, again, that angle is made up by a secant and a chord. So we just wanted to point that out. This one, however, let's look at this example over here. The endpoint of the arc contained in the secant line, as it moves closer to the vertex of the inscribed angle, the relationship measure of angle BDA is equal to 1/2 measure of arc AB continues to hold true. So even when it looks kind of funky, notice that this secant line is almost looking like it's on the outside of the circle, but it is still crossing the circle in 2 points. And that rule still holds true, where the measure of angle BDA is still going to be half of whatever arc AB is, as long as it is touching, as long as this secant line is touching the circle twice, which it is here. And the only reason we really know that is because they have those points B and D marked. However, look at when point B reaches point D, so when they become one. So now we only have 1 point of intersection. This was secant BD, but now it's not a secant anymore, it's a tangent, because this line only crosses the circle one time at point D. Now it's a tangent. So the measure of angle EDA is half of the measure of arc DFA. It still is the same theorem. So that's kind of cool to note, and that's what we want to talk about today. This is the first theorem we want to talk about. It's your inscribed angle theorem, but it also applies to a chord now and a tangent. This angle, but it's the entire angle, EDA, so some of that goes outside the circle, that angle is still equal to half of the arc measure. So that inscribed angle theorem actually still holds true. And that brings us to our tangent theorem. A line that is tangent to a circle is perpendicular to the radius of the circle at the point of tangency. So notice here, we have a radius drawn out to, here's our tangent line. Remember, a tangent line means it only touches the circle one time, at point P in this case. A line that is tangent to a circle is perpendicular to a radius of the circle at the point of tangency. There is always going to be a radius we can draw in that will give a 90-degree angle there. And vice versa, if we have a line that is perpendicular to a radius of a circle at its endpoint on the circle, that means that that line is tangent to the circle. So we could automatically, if we knew that there was that right angle right there, we automatically know that line is tangent to the circle. And that helps us prove that lines are tangent to a circle. If there's a right angle formed with the radius on the circle, then that means that that line is tangent to the circle. So those are just some important key concepts and theorems to get us started today.